Okay, all right. So just a few things, kind of give you an idea of what we're going to do today. Going to kind of tell you where everything is, remind you of what you're working on, then kind of do a review, because I have noticed some people are still struggling, which is fine. I completely understand that. And I have some things that will hopefully help you, okay? Thank you. Morning. Okay. And then Tuesday's class, you can meet down in the lab, okay? You continue working on your homework, but I also want to show you the wind tunnel and take some pitot measurements and profile the tunnel. So I'll have different groups profiling certain sections of the tunnel, okay? Some of you might have already done it before, but it's good review. If you have, you can help the other groups, okay? And with the wind tunnel, what I'll have you do is make a contour map for me of the certain section that you pick, okay? So if you forget, that's fine. I'll come down here and grab everyone and bring it down, okay, on Tuesday. So that's the plan for Tuesday. The following Thursday, we'll see how everything is going. If you still need a little bit more time, I may start something new or figure out where everyone is, okay? So the first thing that I just kind of want to point out is in Blackboard, I uploaded a whole bunch of stuff the other day. So here is day 1 video of week 1, day 2. If you open up this, this is a Word file. Oh, I already have it open. Sorry. That talks about. Oh, that was loud. You don't want it that loud. You don't need it. The types of motion, okay? And this, you will use some of these equations for the homework, but really the bottom line for this homework is to identify a few, like, okay, is it moving? Are we looking at rotation? Use that equation that I'm going to show you here in a second. Do the partial derivative. That's all I'm asking you pretty much how to do. There is 1 or 2 equations on Streamlines. That is important too, okay? But for the most part, it's identifying the equation and practicing the math behind it. So I want to show you why these equations, why use partial differentiation, okay? So this Word file is for you to print off. You can use for the exam. But it goes through the different types of motion. So you have rate of translation, which is just movement. You have rotation. You have it expanding in one direction. It could be expanding in this direction, but also shrinking in the other direction. Or you have this type, what we call shear. Okay. Now, the video that's below this Word file is a good review, but then it actually goes through and it's like a lecture class that I snap that talks about types of motion, okay? So you can go into a little bit more detail with that. All right, so if you look down here, there's going to be a few questions in the homework that, okay, rate of translation. Do you want to figure out what the rate of translation is, how much this fluid particle is moving? That's all it is the velocity profile. If you want to figure out if a velocity profile is rotating, you use this one, angular velocity. This is strain rate, okay? There's actually 3 different types. This is in the X, the Y, and the Z, okay? Is it stretching or compressing in the X? Is it stretching or compressing in the Y, okay? Then down below, this is what they call volumetric strain rate. If you take, and I have a little MATLAB script that I'll show you, but if you have a rectangle, and then this moves in a fluid, and it stretches in this direction, but shrinks in the same amount of that direction, okay, that means it's keeping the same amount of volume, it's being compressed. But if something stretches more in one direction than doesn't shrink much in that one other direction, that's compressible. Okay? So we can use this volumetric strain rate to determine if it's incompressible or compressible type of fluid. Shear strain, this deals with like the pinching that I showed you up top. Is it shearing this type of fluid? Okay. And then don't worry, this is just combining a few things in these. And then the last thing is there is a few questions on the homework that deal with vorticity. This is the same thing as omega. They just got rid of the 1/2, if you notice. Okay, and usually they don't say they don't use omega. They just use vorticity. Okay. So really, when you get to these questions, if you say, okay, I'm looking for vorticity, just grab this equation, write it down, and then cancel what you can for partial derivatives. All right. So here is, and I posted this on MATLAB so you can download it and see how I program this. But this is just kind of to show you what's happening to a fluid particle, okay, in a flow. So what we're doing is we're looking at this box, this red box. That's fluid at one time. You see these black, green, and red lines? These are streamlines, okay? If you just had the streamlines, would you be able to tell me what way this thing is going to move? No. What else did I include? There. Or velocity vectors would be an engineering term, okay? So this thing is going to go down and to the right, okay? But we don't know its motion, okay? Is it going to stretch in the X, shrink in the Y? Is it going to rotate? What is it going to do, okay? Well, I can show you. So as this thing moves down and to the right, does it rotate? No. So there's no omega in vorticity, or there's zero. Okay? But it does. Is there any shearing going on? The corners, do they pinch? No. But there is strain rate, linear strain rate. What happens in the X? It increases, and what happens in the Y? And it actually does the same amount in both directions every time. So it's incompressible. Okay? So what I'm trying to get you to do, why I do this chapter first, trust me, things will get a lot easier. We'll do more like some of the forces and equations later on. But everything that we're doing here, the contour maps, velocity vectors, we're all going to kind of see it later on in Streamlines. Okay. So this, you can download this and run it and see how I programmed it, and you can change some cool things. Okay. So I wanted to show you this. This kind of deals with the types of motion. What else did I have on here? That's the MATLAB code here. And then I don't know how many people watch this, but let's watch this. I made some people watch this the other day. Is it not going to work? Oh, here we go. Some of you probably see this.
The funk soul rubber, check it out now. The funk soul rubber,
it all deals with fluid mechanics.
the funk soul rubber, the funk soul rubber, check it out now. The funk soul rubber, right about now. The funk soul rubber, right about now.
Internet's a little slow. So he obviously changed his drag force, right? But you could tell, you could actually plot streamlines before and after, and you would notice, okay? I have no idea if you can do that in actual racing, but I don't see why not.
So it doesn't make any sense to me because it wasn't pedal. How did he pass it? How did he go faster once he took his legs off the pedals?
It's because he changed the amount of drag
That would
generated.
increase his deceleration, but it wouldn't increase his acceleration.
He's going down a hill. Yeah. Later on this semester, we'll show you. Yeah. So, that is basically, if you took a snip, whatever before and after, okay, you would notice the streamlines are different, velocity vectors are different, and that all deals with contour maps and plotting, okay? So that's why I do this chapter first, okay? But it also gets you to refresh those lovely math skills that you forgot. So that's in here. Other thing I wanted to tell you about in here is I posted the final project for you to start if you want. So this deals with using ANSYS. And all I want you to do is pick, you're going to do this first part, which is a tutorial that has PDF in it. Let me open it up. And then this second part I'll show you is 2 more tutorials that you can pick from. You could do it in ANSYS, or actually after that you could do it in Inventor. So some of this, you could work in groups, that's fine with me. But basically what you're going to do is you're going to draw this, and you're going to look at, you're going to put different temperatures in here. So it's a little bit of heat transfer, a little bit of fluid mechanics, okay? So what you're going to do is you're going to draw it, you're going to run it, and then you're going to finally get into Fluent. And once you get, you don't have to do all 71 pages. If you notice, there's a lot of like big, it goes pretty fast once you get going. Yeah. No, because I might have skipped it. Yeah, this is it. It's in the lab, or you can download it on your computer. Yep. 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 So you're going to get it once you get this. Okay, there's going to be different numbers because you're using a different update. So I'll know if you just snip that. Okay. But this is what you're going to get, and once you get this, you're done. Okay. Photoshop the new numbers. Yeah. But you don't know the new numbers. I do.
Yeah, right.
So
One person in class does it, snips it, sends it to everyone else.
that wouldn't be very ethical, right? That wouldn't be very ethical.
I don't know what you're talking about. That's called collaboration.
No, that's called cheating.
What if, I don't know, if all just work as one big class?
So that's this one, and then part 2 and 3 are. It's a link. There's a couple links in here you can pick tutorials from. So you can get started now. You could do from this link right here. There's a whole bunch of ANSYS tutorials, like a wing or an airfoil. There's other things in there, and just pick another one here. So you're really going to do 3 tutorials. Okay. If you're working on capstone and you have a capstone and you're doing stuff with Fluent or something like that, let me know, and that could be your final project. Okay. So it really won't take you too long to do.
Is there some kind of report?
Nope. Just show me the final result. Yep. Yep.
They have stuff doing some HVAC stuff.
So if you can model that in Fluent, that could be your final project. Kill 2 birds with 1 stone on that one. Okay. What else do I got in here? Do I have anything else? I don't think I do. So you're working on the homework now. Okay, I think there's 12 questions, but really 11 of them are kind of short. Okay, just find the equation. Like it's going to be find stagnation point. Remember what the stagnation equations were? Like what do you set the velocities equal to? 0. Okay, Ryan, you might have to watch some videos to catch up. Stagnation, and then the next I think question is find acceleration. How do you find acceleration in fluid flow? Well, go to here. They're right in your book. Or you can grab this at 5709 and write those equations down. Okay? So why you have AX, AY, AZ. Why is there 3 different types of acceleration? Because if you take, just like you took that square chunk of fluid that I showed you in that MATLAB script, that could be like a square. All I can think right now is soap. I don't know why, but anything. It could be this mouse, right? This thing could accelerate X, Y, or Z. Same exact thing happens for fluid, okay? This cube, let's run this again and show you. That cube right there, actually it's just a box, but you could take in and out of the page as the cube. That thing could accelerate in the X, the Y, and the Z direction. However, it's a little bit more complicated for fluids because we know that moves. There's time involved. If it's unsteady, it can move in the X, the Y, and the Z. So that's why you have partial differentiation here. Okay? I'm not asking you where these equations come from. All I'm saying is find acceleration in the X, you write this down, practice your math skills. Okay? Because this is where it's finally applied now. Again, if it's looking for, I think there is one where it says angular velocity. Just write that equation down and cancel things. Okay? These I, J, and K's, okay, actually tell you the kind of the direction it's rotating at. So if you have a velocity profile that's only U and V, what does that mean? If it's only U and V, it's 2D. Okay? Is there any W or Z? No. These two terms go away. That goes away. That goes away. So you're only left with that last chunk right there. And guess what? It's rotating in the K, meaning if this direction is my X and Y, so I'm walking this way, it's actually rotating this way. Okay? Very similar to like moments, your right hand rule, how like it's rotating that way. That's what that's doing. Okay? I think one of the answers you're going to get is 0, and there might be another one that's not 0. If you have a flow that is rotating, we call that rotational. If it's not rotating, it's called irrotational. Okay, so just some verbs or some terminology for you to remember. Questions so far about where everything is, what you're doing for that? Okay, so now let's review. Where are we here? Right here. So we did this last class, and I showed you the difference, but I'm going to run it. I can upload this MATLAB code too to help you. Come on. What's going on here? Paused. Oh, I know why. So I got to let the motion move. Then I got to change folder. There we go. Okay, so where did my equations go? Right here. Let me magnify it for you. There. Okay, so we use these particular U and V equations. So U is U naught plus V times X, and V is negative V times Y. Some random profile. And I did it to kind of look at like certain sections. It looks like it's flow through a pipe. Okay, some random pipe. U naught and V are just constants randomly. I can pick anything I want. I put this in, and then I took the square root to find the magnitude. Right. Then I plotted. So if we go to the plot, again, I showed you this, but it's good review. This was the plot of U, little u. And if you notice, the equation we had was only a function of x. So what does that mean? That means that u only changes in the x. So every section will have a different value, but along the y, it's always the same. Okay. Now, if we look at the v, again, that's only a function of y. So that's only going to change in the y and not in the x. Okay? Then we combine these, and that's how we get the velocity magnitude, which is kind of looks like this. Well, what would one look like if it was a function of x and y? Well, I have an example. So let me show you. To make sure you kind of understand where this is coming from, I think I put return there. Magnify is in the way. Oops. So let me zoom in and show you. So here's our just some random values that I made just to kind of show you. So u is a function of x and y now. Same thing with v. Well, what does that look like? Well, that just means it has a different velocity vector at certain x and y locations. So I did a subplot. This one. Let me blow this up. It's still steady flow because there's no time involved, right? So that means for u at 5 and 0, that's going to be, what is that, light blue, like 2 meters per second? That's always going to be 2 meters per second there. But if you notice, it changes what the velocity profile in that direction is at certain locations. Okay? Same thing with v. So this just means that every location in the y, or this velocity profile, is different because it's a function of x and y. Okay? So do you see the difference between this one and the one I just showed you? One's going to be functions of x and y. Oh, where'd it go? So this is the original one, and then now this one now is just functions of x and y. If I put time in there, this would be one snapshot at time of 0. Then you run it again, and guess what? You're going to get a whole new contour map, but it would have this kind of shape to it. Okay? Does that make sense now? Does it clear up any other issues that people are having? Okay. So if I tell you, oh, right there. Let me zoom back in. We have these two equations. And I wanted to find the acceleration. What would I do in the x and the y? Well, you just go to these equations right here. And your partials now are going to be different, right? This term right here, du dx, is going to be a term. And du dy will be a term. Okay? So really, all you're doing is you're adding an extra term. Makes it a little bit long. Okay? Questions? Okay. So we went through that, went through these equations. Then we also did, let's see, where did I do that? At the end? Streamlines? Yep. Actually, I just want to show you, then we'll write them down. Right here. So we understand, okay, we have contour maps, we have vector plots, we got streamlines to tell us kind of where the flow is rotating, maybe possibly how the flow is going over some sort of object. We know that we could have different velocity profiles, we can find accelerations, we can figure out if this thing is rotating, how it's stretching, or a chunk of mass. Then the next big thing in this chapter is understanding how to find streamlines. Okay? They come from this derivation that I showed you before. The velocity is right here, this vector, and the streamline is always tangent to that. And we just broke this up into components, u and v. And then we had where the surface, or where the triangle touched the streamline, we did another circle, or another triangle. So we had similar triangles. And we ended up getting this formula, dx over u equals dy over v. Anytime you have to calculate streamlines, that's what you're going to write down if it's 2D. And I think that's all we're going to do in the class here. If you have 2D, you're just going to write this down. U and v, where do they come from? Come from your velocity equation. Okay? So right here, this was the exact same problem we've been working on. This term right here is u. This term right here is v. Then what did we do? We just plugged them in right here, right? And then I'm going to mute it. You don't need to hear me talking over myself. I just want to get a little further. There. So going from here to here is something that I want you to practice with. Okay? That is the math that you need to remember. Okay? Is how to integrate from here down to here if you don't have limits. In dynamics, what did I force you to do? Put limits in, right? Because we knew them. We have no idea what the limits are right here. So you leave them blank, and what you do is you just add a constant after you integrate. Okay? Then, once you have the solution, then it's, okay, how do we plot that solution? That's kind of where I can help you with this state, okay? So if I go back to here and we go to homework, in here is your homework, but also I gave you a PDF about streamlines, how to calculate them, and a video on how to actually make the MATLAB code for it. Anybody watch that yet? No? Okay, good. So why don't we look at it? And we'll go, this could be a good review, okay? So let me open this. So if you want to take these notes down or just listen, it's up to you. I mean, it's right in Blackboard. I don't know why I can't open it. So let me just go back to my own homepage and do it. Let's see here. Week 1. Is it in here? Nope. This is what I'm going to do. Open a new tab because I can't remember where I put it. Get rid of this. And can I zoom in? No, I don't want to do that. Oh, that zoomed that in. I can do this though. Everything's got to be so different in every program. Okay. I'm clicking too much. Okay. Here is, like I talked about before, the bottom. This is a bottom plate. This is the top plate. Bottom plate's fixed. Top plate's moving at some constant speed. And we have fluid that sticks at both surfaces. Okay? Hopefully now you understand, okay, we could do a lot of things with this right now. We could make vector plots. We could make contour plots. We could make time plots. We could do whatever we wanted to this profile. Okay? So what I showed you here is the velocity vector in terms of I and j components. So it's only 2D, so we have u and v. We have this part right here, which is this velocity times y over h in the I direction. Is that 0? It is. Yep. Because is there any flow up in that direction? In the v? No, nothing. Absolutely nothing. but I put it there to be complete. The question now becomes is how did I find this? Remember? How did I know that this was the velocity in this direction? Well, what's the velocity down here?
0.
What's the velocity up there? V. What direction is that? Y. Pointing right here. Yep, okay. So delta Y is V, because you do V minus 0. Okay. And then delta X, what's delta Y over delta X? The slope. So all you did here, this is just the equation of a line, y equals mx plus b. Okay? That's all we did. Okay? From 0 to v. That's all we did to find that. Okay. Then we want to find the streamlines. How do we do that? See that right there? Does that look familiar? I just rearranged it, right? That's exactly what I showed you. Here, you're going to write that equation down, or you can do what I did and just write it like this. So I did dy over dx equals v over u. And guess what v is? 0. What's u? V times y over h. Then what do? You separate variables and integrate. Yep. I don't want to go too far. So in the homework, I'm not making you do anything above this. I give you what the velocity profile is. You write this. You separate the variables, and you're going to integrate. What does separated variables mean? You have to figure out what? You have to keep y on one side and x on the other? That's all that means. So when you integrate the left-hand side. What's that going to be? dy squared over 2h. Yes. To the back. What about the right-hand side? Are you sure? It's a constant, right? Okay. So what I did here is I integrated this plus a constant. Integration of 0 is a constant, right? Because if you take the derivative of a constant, that's 0. Okay? Now, when you go in your homework from here down a little bit, try it. My guess is you're probably going to get stuck because there's some log rules that you got to remember. Okay? When you get to that point, come and ask me or ask Dr. G. Okay? Or look online. You can find it online too. Okay? So, what did I do next? All I did was, I keep going down a little bit more. I just solved for y, which is at the end of it. Yeah, perfect. So all you're doing is you're taking the streamline dy over dx is v over x. You're plugging it in and you're integrating to find an equation of y as a function of, did I forget x? Oh no, in this case, it doesn't matter because it's only horizontal. Does that make sense? I could give you any velocity profile, right? All you got to do is pick out u and v, plug them in, and integrate. Now, on a test, I wouldn't give you like your home like log rules. I would make it kind of something that's doable and you wouldn't mess up, okay? Now, once you get this equation, y is your line, and then this should have x or something over there. But in this case, we know that they're all horizontal lines, so it's different. Before I go to the MATLAB, any questions on this? Okay, so let me open up the MATLAB and we'll kind of step by step through this. You can take some notes. I gotta remember where I put it though. Streamline help. I think it was in maybe homework. Maybe this is it. This might be it. Oh. Yep. Okay, I don't have the symbolic toolbox. Which, Andrew, now you know what symbolic toolbox is? Yeah. So the symbolic toolbox in MATLAB, if you ever want to do a differentiation or integration and use sims, that's what the symbolic toolbox is. So if you're going to buy MATLAB, don't buy the $50 one. Buy the $100 one because it comes with every toolbox and will make your life easy. Okay, right there. Let me zoom in again. So this will practice your. Oh, what is going on? For loops, okay? Right there. I mean to give you a headache. Yes, this is a video of how I actually did this. Yep. Okay. Now, oh yeah, I even have delete. So don't worry about the sims. Okay. That's nothing. Okay. So all I did here is get streamlines. So I defined v upper above as some velocity. I divide by h and u, or sorry, y. I showed you what that was already. V was 0, right here. Down here, H, L, V upper, I think I changed them down here. So I'm just defining variables, and I define my x. So in this section that I'm looking at, we go from 0 to 5 inches. Okay. I define C values. What are the C values? Remember? They're the constants in what? In the streamline equation. Right here. See how it's C down there? Let me zoom. Okay. Do you remember what, if you change the C value, what they do? No? Okay. What is Y? Y is your streamline, right? H and V are constants, and C is some other constant. Well, how do we get another streamline? We pick a different C value. So how many streamlines do I have? I got 1, 2, 3, 4. Okay? I just picked these arbitrarily to fit on my graph. Okay? And you see the color? I'm going to make these different colors. Every streamline is going to be a different color. The first one that's correlated with 2 is going to be black, green, red, and blue. Okay? Anybody know why this line is here, line 82? We can kind of look at the note that I have, right? Actually, I'll post this too. I don't know if I actually posted this script, but I'll post it because I think I did before, because it actually tells you what to do, okay? Kind of guides you. This line right here, that's hard to see highlighted, initiates a for loop. Okay? So this streamline, you see how it builds in the for loop? I'm going to initialize it so it runs faster in MATLAB. So anytime you're doing for loops and you know how big a matrix is going to be, initialize it with NANs, not a number. Okay? Because sometimes in the future, if you do something, it's going to make it significantly faster. Okay? So I just did the length of X, which is 0 to 5, and then length of C. So there should be 4 rows, okay, or 4 columns, depending on, I can't remember exactly how I did this, okay, because there's 4 C values. Now, down here, the for loop. You remember how to use for loops? It's for I equals 1, and I did length of C. So how many times am I going to do this loop? 4 times. And every time I do the loop, what am I going to do? I'm going to do it, the calculations based on how big X is. So the first thing I did is, here's my streamline. I do semicolon, comma I equals square root 2CH over V, which we had. And wherever you have C, you have to put parenthesis I. Because what's the first value of I? 1. What's C of 1? 2. Okay? So it's going to first calculate with all the X values a C value of 2. And then boom, I'm going to get 1 line. Okay? Then I plot it. I plot X versus streamline with my colors. You see how I have I here and I have I here? Because you need that inside the loop to know what. Okay, I'm going to color with 1, which is K, which is black. Then I go back up to the loop. I pick C of what? 0.75. Run through the calculations. So let me...
So that would already start at that.
Yes, they do. Yes. However, I think in C it starts at 0, right? Yeah. Yeah, MATLAB, hates zeros. Yep. I just want to make sure it's going to work. Now give me an error again, and then I will pause it. V upper. Oh, I don't need that either. There we go. Okay. So I'm going to pause and I'm going to type streamline. Actually, let's do that first. Just to show you how the loop is working, okay? So if we go down here first, and we look, you see how these are all NANs? Initially, this whole thing was NAN. With my first time through the loop, I calculate all the X values are down here. This is the first column of what C value? 2, right? Mm-hmm. Okay. What is the X value corresponding to this value right here? 0. 0. What about all the way at the end? What's this value? I think it was 5, right? Yeah, it's the last value. Oops, I went the wrong way. Again, we go up here. This first number right here corresponds to a C value for this whole column of 2. But this first value has an X of 0. The next one's 0.1, then 0.2, and all the way down to 5. And then, if we look at the graph, this is right here. That black is the first streamline somewhere in our range that we picked. Then if we hit enter, it made some random value green, but if you look, it actually filled in, whoops, that's the first one, the second column, which has the next C value, which is the next streamline. And again, this is corresponding to x of 0 by 0.1 all the way down to 5. Then I can keep doing this. It keeps filling in the matrix and gives us our contour plot, or our streamline. Okay? So all of these are horizontal. We know the flow is going this way because we looked at it beforehand. Okay? But this is the streamline showing you how this flow is moving in between these plates. But it practices for loops, practices how to program, and helps you with that type of mental set. Okay? Questions? Did I just make everyone go to sleep? Your mind is blown? Yes. I will upload this code, and what you need to do is line by line change what you need to change based on your velocity profile. Everything is going to be the same code base, but what's going to be different? This equation right here, right? You may have different constant. You might have h and v upper. And anybody know why I put 0 times x here? No, it's not the y value. I did this because, is there any x in this equation? No. No. That's how I made it I tricked MATLAB into making it a matrix. Okay. You may have, your x might be different. I don't know if it goes 0 to 5, but you can change that. So what homework number question deals with that one? Is that 5? Okay. Yep. Okay. So I'll upload this. So let's just look at the homework. Questions? Questions? No questions? Everyone's good? Your brain is probably accelerating with fluid in there right now, right? Figure out what your accelerations are. Maybe you got shear strain rate. No? Volumetric strain rate? You don't know? I forgot what I was doing. I lost track. Huh? Homework. You're floating? Uploading. Yes. I uploaded the homework, but I'll upload that. But let's look at the homework. I already have it open. Look at that. I was already prepared. Oh,
Now you're double prepared.
I'm double prepared.
That is actually negative now. It's that you're 0% prepared.
I wish other people were double prepared. Okay. Let's start right from the beginning. Number 1. Can you see this? Which is there a stagnation point in the flow field? You just set U and V, set them equal to 0 and solve for x and y. Number 2, calculate the acceleration field, AX and AY. Have I given you those equations? I have. Practice. Really what you're doing is you're practicing your partial differentiation. Okay? And understanding where we apply the math skills to do some of this. Next one, that's more, this one and the next one are more for you just to kind of look at and understand, is it a contour map? Is it a vector plot? What are we looking at here? That's kind of for those. All right. Number 5, this is where I want you to calculate what I just did, the streamlines. Okay? I'll upload the code, so you have the code. So really, what is U? 4.35 plus 0.656 times x. What's v? This. Okay? So you plug it into the streamline equation, you integrate. You get an equation for y as a function of x. That's your streamline. You plug that back into the MATLAB code and you can do streamlines. Okay? And I give you x 0 to 5. Oh, I already do 0 to 5. Look at that. Okay? Why did I give you y? This is the double of the y. Anybody know, like, are you going to do really anything with 0 to 6? No. Well, the reason I gave you this is because when you plot the streamlines, you pick your constants. I want the streamline between, for x, 0 to 5, but y in your graph, I want a 0 to 6. So you can pick any streamline, but do your y limbs and x limbs to be in that range. And make sure you have enough streamlines in there. That's all that's for, okay? So when you get to this, and I've seen it before, there's nowhere you're going to put that. Nowhere you're going to say y equals 0 to 6. You don't need that. Your only spot you're going to probably do it is at the end where you do y lim for your plot. Okay? So that we just covered that. I just showed you kind of how to do them. I didn't show you the math because that we have courses for. But if you get stuck, ask me or ask the math instructor or whoever's around. They should help you. Okay? Number 6. This is the vorticity. What did the vorticity equation look like? Remember? That was this last one on the sheet. It's in your book too, but it's right here. All you got to do is write that equation down and cancel things. Okay? The next one, angular velocity. What did I say angular velocity was? Omega. So we have that equation. The next one, this one is the streamline one. Again, this one, use the streamline equation and it wants you to pass through the point. Okay? Try that. That one, I got to look at it again. I haven't looked at it in a while. I just want to make sure that one's doable. So if you get stuck on it, it's okay. I could probably do that one next time in class. 9. This again, vorticity. All right. This one, irrotational. What did I tell you what irrotational was? Well, I'll let you look it up. I said it. It's either rotating or not rotating. One of those two, 50-50 chance. Last two are shear strain and volumetric strain. Okay? You have those equations. Just look at that sheet. The shear strain, I give you those. The volumetric, I give you those. Again, practice partial differentiation. And I think that was it. Okay? September 5th is when? Yeah, that's good time. Because Tuesday you're going to meet me in the lab. We'll go through, you can continue working on this. I have computers in there. You can work on the MATLAB script for Streamlines. And I might do 9 and maybe post that for you. Okay, the Streamline, other stream, or which, no, not 9, 8. I'll do that one for you. Okay, but I still want it in your homework. Okay? Questions?
Next Thursday.
This is due next Thursday, yep. Actually, next Thursday, what do I have for planning? Ooh, okay. Next Thursday is finally where we're going to look at momentum analysis. So looking at forces in pipes as water goes through it, or when you squirt someone in the face, what force is generated, okay? Actually, a lot of that will deal with propulsions too. So students in propulsions, this is where some of this is coming from. So, okay. Really, don't feel overwhelmed, because really it's what equation am I looking at? Practice my math skills. Okay. And the bottom line is make sure you understand contour maps, vector plots, and then streamlines. Okay. And then for the wind tunnel, I'll have really what I'm going to have you do. I'll have a write-up for you. All I want is you to profile a section of the tunnel. It could be in the X or the Y, but we're going to pick points. And you're going to make a contour plot. and I'll have like an outline for you to follow for that in MATLAB, okay? So make sure you understand how to make a contour plot. It's actually very, very simple. Like 3 lines and you're done in MATLAB. X, Y, and then you could do contour F and then fill out everything, okay? Very, very simple. But I want to make sure you understand how to do it, because if you ever need to, you can. Okay, a lot of information today. Go back wherever you need to, review it. Giving you a lot of information. We have 3 videos now for lecture. There's a video on the MATLAB code, how to make it. And right now I'm going to upload the MATLAB script for the Streamlines, so you have that too. You need to change it, but where do you need to change it is what you got to do, okay? Any questions? If you have questions, you can always email me, like most people do. If you do have a question, just take a picture of your work, send it to me. Then I know what you're kind of looking at. Other than that, I'm not sure what else. So, okay, thank you. So remember, Tuesday, meet in the lab.